Alright, hello 7th grade. We are going to go ahead and get started on the last section of Chapter 10, which is also actually the last section of your entire textbook. So, we are almost done. Yay! So, we're going on to the next section here, which is all about two-way tables. There are cutouts that go along with this section, so if you did not print those out and cut them out yet, please pause the video and do so. I already pasted in our first cutout, and this is just an example of what a two-way table looks like. The reason it's called a two-way table is because it's showing us two different amounts, and it's going two different ways. So this is for, looks like boys and girls in a school, maybe students, who are voting for something or against something. Maybe it's, I don't know, cutting recess time down. People who are voting for it, I don't know why, and people who are voting against it. So, we can tell a couple different things from this two-way table. We can see how many people voted for this, how many people voted against this, but we can also see how many boys in total voted and how many girls in total voted. So I can see that 16 people were for it, 14 were against, and 15 boys voted, 15 girls voted. Now this down in the corner, you'll notice no matter which way I add either columns or rows, I get 30. Because if I add up all the votes, it's 30 total votes because 30 total people voted. That just makes sense. So that's how a two-way table works. You can look at the columns or you can look at the rows. Remember, columns go top to bottom, rows go across. So what we are going to do is we are going to make a two-way table. That is going to be the first thing that we do. So, this is where your second cutout is going to come in. I'm actually at the bottom of the page here, so I'm going to flip to a new page, and I'm going to go to the top. I'm going to put a number 1, and I'm going to write making a two-way table. Okay, and the next one you should look something like this. So I'm actually going to put it right about in the middle here, and I'm going to pause and glue in. Please do the same. Alright, so mine is glued in. I'm going to go ahead and get started. Actually, before I do, let me try to make this a little clearer. That's pretty good. Okay. So it says 50 moviegoers were surveyed about their favorite movie types. 13 men and 6 women chose action as their favorite type. 8 men and 8 women chose drama. 5 men, 4 women chose comedy. 4 men, 2 women chose animated. Alright, so here is what you're going to do. And it doesn't really matter if you put these as the columns or the rows. It's kind of up to you. The way I like to do it is, and I'm just going to move this down a little bit, try to keep that in the frame as I work. The way I like to do it is, since there's only 2 kinds of people choosing, men and women, I usually like to make them my rows. So going across like this. So here, actually I'm going to space it out as much as I can. I'll put men and women. Okay, just like that. Alright, and then underneath, I'm going to write total, because remember, our rows and our columns both have totals. Alright, so we have men and women, took care of those, and we will have a total at the bottom. But we also have different kinds of movies, and these I'm going to make my columns. So here I'll put action, drama, comedy, animated, I'm just going to abbreviate it, and total. Okay. If you want to put lines to make it look more like a table, you're welcome to. I'm just going to leave it as is. All right, so let's take care of action first. That's our first bullet point. It says 13 men and 6 women chose action. So 13 men, 6 women. So how many people altogether chose action? Well, 19 of them did. Okay, so far so good. 8 men and 8 women chose drama. So 8 men and 8 women. So that means in total 16 people chose drama. Comedy, 5 men, 4 women, which means 9 people liked comedy as their favorite. And then 4 men, 2 women. So 6 people picked animated. Okay, so I'm almost done. I just have to do this one, and I can do it now because I've got all of my columns filled in. I'm going to add each of these. So this total, actually pause for a sec. This total told me how many people chose that particular genre. This total is going to tell me how many men voted in this particular survey. So let's add these. 13 and 8 would give me 21. 21 and 9 would give me 30. Okay. 6 and 8 would give me 14. 14 plus 6 would give me 20. So this is the final piece here. And it should match 50 movie goers because this tells me how many people in total were in the survey, and it should add up to 50 this way and add up to 50 that way. If it doesn't, I have to go back and check. This way is pretty easy to check because if I do 30 plus 20, well, that does give me 50. Let's add all of these up and see if it gives me 50. Let's see. I'll add these two first. 19 and 16 would be 35 plus 15. Yep, that equals 50. Okay, so that is how you make a two-way table. You start by filling it in, you add up your totals, and then you get your final total, which should be the total number of people in that survey. And you should be able to add your totals from the columns and the rows, and it should equal the same number. If it doesn't, you do have to go back and check. Alright, the next thing we're going to talk about is related to a two-way table, but this is called a relative frequency table. And it's set up the same way. We just calculate something else once we are all done with making our frequency table. And there's actually a couple cutouts that go along with this. This is the first one. It's like the descriptor. And then this is the second one. I'm going to try to see if I can get them next to each other by trimming them down a bit. If you have to go, one on top of the other, that's fine. But I'm going to pause and glue in. Please do the same. Hey guys, I just realized that those two cutouts don't actually go together. I apologize for that. I meant to do one other example of a of a two-way table before we got to relative frequency. So this one up here, we're actually going to call A, and then this one down here we're going to call B. Just kind of put it in where you can. I apologize for that. We're going to go ahead and make one more two-way table, and then we will get on to relative frequency. Okay, so it says 30 students were surveyed about their favorite type of lunch. 6 girls and 8 boys chose turkey sandwiches. 7 girls and 3 boys chose grilled chicken. 4 girls and 2 boys chose veggie pizza. Make a two-way table of the frequencies for the data. Use the frequency table to determine the least popular lunch choice in the survey. So we're going to go ahead. Actually, what we'll do, I'm going to have you pause. You're going to make your own two-way table. And then when you're done, go ahead and hit play, and we will see if our two tables match. So I'm going to pause and create mine. I would like you to pause and create yours as well. Alright, so here is what your two-way table should look like. So what I did is I made my rows to be the boys and the girls, and then my columns to be the different kinds of lunches that they had. The turkey sandwich, the grilled chicken, and the veggie pizza. And then what I did is I went and filled in all of the numbers. So for this one, 6 girls, 8 boys, 7 girls, 3 boys, 4 girls, 2 boys, and then calculated the totals. And then I just double checked that everything added up to 30, because all your rows and columns should add up to 30. So 17 and 13 does make 30. 14 and 10 makes 24 plus 6. Yep, that makes 30 as well. So using this, it's kind of easy to say, but the least popular lunch choice is going to have to be our veggie pizza, because only 6 people total like to have that as their lunch. The turkey sandwich seems to be the most popular because 14 people like to have that for their lunch. So there we go. And you might be able to say that this survey isn't quite fair, because if you look, more girls than boys voted. If they wanted it to be totally fair, maybe they would do like a 50-50 split, 15 girls and 15 boys. But you know, that's just my opinion. Now we can go ahead and move on to relative frequency. So let's rewrite our number 2. And we're on relative frequency. And we still want this one that we were using. And I already have some glue on, so I'm just going to smush that in there. And this one as well. So I'm going to pause and glue that other one in. Please do the same. Okay, so mine are glued in. We are going to get started. Now, a relative frequency table. Okay. Our relative frequency measures kind of like the percentage of our totals. And I'm going to show you exactly what I mean as we start to do this first problem. And this first one that we do is going to be A, so I'm going to put an A here, and we're going to follow along with what is written here in the little side blurb. So it says the frequency table shows the hair and eye color of 25 students. There's my total. Is there evidence that blue eyes are more common for students with blonde hair than for those with black hair? Now, here is what we're going to do. You can find relative frequency of both rows and columns. So how do you know which one you're supposed to do? Am I supposed to find the relative frequency of the rows, or am I supposed to do it of the columns? So here's how you know which one you're supposed to do. They are looking at blue eyes, but which two are they comparing? Blue eyes with blonde hair and blue eyes with black hair. I can see blonde and black are 2 columns. So I'm going to find the relative frequency of the columns, and then I'll be able to answer this question. So here's what you're going to do. You're going to kind of copy the categories that you have for the frequency, I keep saying frequency table, for the two-way table that is above. So I'm going to pause, I'm going to copy these down, and then we'll go from there. Alright, I did decide to put lines in between this time. Let me do this, because I was getting a little close with my black and my brown there. I wanted to keep them separate. Okay, so what we're going to do, we are going to find the percent of the total for our rows. Here's what I mean. I'm going to recopy my totals here. My total for blonde was 6 people, 9 people, 10 people, and I had 25 total. Okay? So 6, 15, and 4. So all I did was recopy my totals. What we're going to do, I'm going to measure each of these out of 6, because that is my total for the column. So 3 people out of 6 were blonde and blue-eyed. So if I were to write that as a percent, that would be, well, that would reduce to 1/2, and I know that 1/2 is 50%. Brown was 2 out of 6, which if I reduce that, that would be 1/3. And you may have to plug that into a calculator. Remember, you can turn it into a percent by taking your numerator and dividing by your denominator, and that'll give it to you as a decimal, but then you can easily turn it into a percent. But this is about 33 1/3%. I'll just round to the nearest tenth. And green was 1 out of 6, and that one I don't know off the top of my head, so I'm going to go ahead and grab a calculator and I'll be right back. Alright, so 1/6 as a percent, and I'm going to just round to the nearest tenth of a percent, would be 16.7%. Okay, I'm going to go ahead and do the rest of these. So here's what you're going to do. You're going to take whatever was in here, put it over your total for the column, and then write it as a percent. I'm going to do it for the rest of these, and I'll be back in just a sec. Alright, so I went ahead and converted each of these into a percent. You'll notice that it's just the number that I had up in my two-way table divided by whatever the total for that column was. Okay, so I wrote each of these as a percent. If you notice, if I add up the percents, they total to 100%, as they should, because this is what we're measuring them out of, and it should add up to 100%. So, let's go back and look at the question and see if we can answer that. So it says, is there evidence that blue eyes are more common for students with blonde hair than for those with black hair? Explain. Well, if we look at the percentages that we calculated, we're looking at this one here and this one, because we're looking at blue eyes with blonde hair and black hair. So it looks like students with blonde hair, where 50% of them had blue eyes. But students who had black hair, only 11% of them, a little over 11%, had blue eyes. So to me, it would say, yeah, it is more likely that someone who has blonde hair is going to have blue eyes based on this, because 50% is higher than 11%. So yes, there is evidence that it's more common with students with blonde hair to have blue eyes. Okay? That is a relative frequency table. We're going to follow this same two-way table. We're going to make another relative frequency table, but this time we're going to be answering a different question. So how we calculate our percentages is going to be a little bit different. We did it in columns this time, but now we're going to be doing the rows. So let's go, whoops. I'm going to go down here to B. Okay, and this time we're going to be answering this question. I don't have a cutout for this one, so you are going to have to write it. Is there evidence that brown hair is more common for students with brown eyes or green eyes? Okay. Now, here's how you know that this time you have to do the rows instead. Yes, we are looking at brown hair, but for which two categories? Brown eyes and green eyes. If you notice, brown eyes, green eyes. So this time we're going to calculate our percentages going across the rows. So once again, I am going to recopy my categories from the two-way table above. I'm going to pause and do that, and you guys should do the same. All right, so I have that copied down. This time, I'm going to rewrite my totals, just like I did before. So the totals were 6, 9, 10, and 25. And, whoops, get out of here. And then 6, 15, and 4. Okay. We're now going to be using the total from the end of the row to help calculate our percentage. So I'll do the first one. We're not looking at blue eyes, but I'll just use that as my example set. So this was 3 out of 6, which we already know that one. That should be 50%. Oh, this one's going to be easy. You know why, guys? Because the total here and the total here are the same. I already have the percentages calculated. This shouldn't be too bad. We know that 1/6, we already calculated that. That should be 16.7%. And we also did 2/6, because that reduces down to 1/3. So it would be 33.3%. If you notice, if you add these up, it would total to 100%. Because if I did 6 out of 6, that's 100%. Let's try the brown eyes. We had 2, but this time we're measuring it out of 15. So if you have your calculator close by, I've got my handy dandy calculator, which also doubles as a phone. So all you have to do to convert a fraction into a percent is do this. Take the numerator, which in this case is 2, divide by the denominator, which in this case is 15. We get some really long repeating decimal, but all you got to do is take that decimal point, bump it over 1, 2 spaces. So this would be 13.3 repeating percent, but I'm just going to write it as 13.3%. Okay, the next one is 7 out of 15. This is going to be pretty close to half. You know how I know? Because half of 15 is 7.5. So I know this is going to be really close. So 7 divide 15. Ooh, I was really good. I'll write this to the nearest tenth as 46.7%. And then the last one is 6 out of 15, which would reduce down to 2/5. Yeah, 40%. Go ahead and calculate the last row on your own, and then we will talk through the question and we will answer it. I'm going to pause and calculate the last row myself. Okay, there we go. So I'm going to go ahead and take a look at this and then try to answer the question that we wrote in the beginning. So, is there evidence that brown hair is more common for students with, so we're looking at brown eyes and green eyes, and we're specifically focusing on brown hair. Oh, interesting. Very interesting. So it seems that, at least according to this two-way table, it is more common for students with green eyes to have brown hair, because if you look, green eyes and brown hair, that came out to 50% of all the people that had green eyes. Now, granted, there were only about 4 people that they surveyed that had green eyes, but of those 4, 50% of them had brown hair. If we look at all the people who had brown hair, there were 15 of them, but most of them had brown eyes had black hair. So according to this, it's more common for students with green eyes to have brown hair. So that is how you make a relative frequency table. There's no IXL topic that goes along with it that I can find, so we're just doing the lesson for today. So that is the end of that there, guys.